Welcome to the lesson. Today's lesson is on the sine ratio. You may never even have heard of it. You may have wondered how we pronounced it. S-I-N-E is the sine ratio, and we're going to be using that to find a side. So let's crack on, get the job done. Trigonometry means three-angled measure, and therefore it deals with angles in triangles. In this section, we are only looking at right-angled triangles. It's important to remember that. And in each case, we will be given one length and one angle, and we will be asked to find the length of one of the other sides. Here is a right-angled triangle, and there is an angle marked in. Imagine the angle was an eye, and the eye of the triangle always looks at the opposite side. We probably know that the side opposite the right angle is called the hypotenuse, and the third side of the triangle we call the adjacent. Here's another right angled triangle, and this time that angle is marked in. Remember, if that were an eye, it looks at the opposite side. The hypotenuse is opposite the right angle, and the third side is the adjacent. The sine ratio, spelled S-I-N-E, is the ratio of the opposite side to the hypotenuse in a right-angled triangle. In this example, the opposite side is 10 centimeters and the hypotenuse is 18 centimeters. So the sine of angle C is 10 divided by 18. But in the second example, the angle is marked in at point A. Therefore, we don't write sine C, we will be writing sine A equals the opposite of the hypotenuse, which is 15 divided by 20. In this example, we have our angle of 30 degrees. So sine 30 degrees equals opposite divided by hypotenuse would give us sine 30 degrees is 8 divided by x. If we press sine 30 degrees on our calculator, we end up with 0.5. So if 0.5 equals 8 divided by x, that must mean that x would have to be 16 centimeters. It would not be unusual to wonder whether the size of the triangle mattered. So just to show you, I've put the protractor on the calculator. That angle is 30 degrees. If we enlarge the triangle, the angle still stays at 30 degrees. I've actually enlarged the triangle by 25%. So AB, which was 8 centimeters, now becomes 10 centimeters. AC, which was 16 centimeters, now becomes 20 centimeters. But let's look at the ratio of sine 30 degrees. That ratio is the opposite side divided by the hypotenuse. 10 divided by 20. That ratio is still 0.5. Therefore, if we enlarge the triangle and change the length of the sides, it matters not. The ratio of sine is still the ratio of the opposite divided by the hypotenuse. So, if a right-angled triangle has got an angle of 30 degrees, the ratio of the opposite side to the hypotenuse is 0.5. There's another one, 10 to 20, 20 to 40, 4 to 8, 14 to 28, 6 to 12. And the ratios of the opposite side to the hypotenuse are all programmed in our calculators under the sine button, because that's what sine is. It's the ratio of the opposite side to the hypotenuse. So you can pick any angle Press the sine button and it will give you the ratio of the opposite side to the hypotenuse for a right angled triangle with that angle in it. Let's see how we can use our knowledge now of this sine ratio to find some missing lengths. In this example, we've got an angle of 35 degrees marked in. Remember, if that was an eye, it'd be looking at the opposite side. So sine 35 degrees would be x divided by 12. We can rearrange that by multiplying both sides by 12 to find x. X would be 12 times sine 35. Press that in on our calculators, and then we would round our answer off, in this case, to 1 decimal place. Let's cement our understanding with more examples. Always check that the angle marked in looks at the opposite side, and we have 25 centimeters, which is our hypotenuse. So sine 55 degrees is opposite over hypotenuse, so that would be x divided by 25. If we then multiply both sides by 25, we have x equals 25 times sine 55. Once again, we would round that off appropriately, 1 decimal place, and there's our answer. Here is a method which is a little shortcut which you may find really useful. First of all, you have to set your triangle up appropriately. S stands for sine, O stands for opposite, and H stands for hypotenuse. But you must get the 3 letters in the right section of the triangle. If we wish to find the opposite side, we place our finger over the O, and that leaves us with S and H next to each other. And in maths, 2 letters next to each other means multiply by. So the opposite is the sine of the angle multiplied by the hypotenuse. If you wish to find the hypotenuse, put your finger over the H, and that leaves us with the opposite divided by sine. Therefore, hypotenuse is found by taking the opposite side and dividing by the sine of the angle. How would it work with this example? We are trying to find x, and x is the opposite side to the 55-degree angle. So we would place our finger over the O for opposite, and that tells us that the opposite is the sine of the angle times by the hypotenuse. Straight away, it gives us an expression for x. We put it into our calculator and we round off appropriately. Similarly, in this example, this time we are trying to find x, which is the hypotenuse. So we place our finger over the H for hypotenuse, and it tells us it's the opposite divided by sine of the angle. 9 divided by sine 28 is 19.17, and we round off appropriately. Let's put all this together with a recap. The sine ratio is a ratio of the opposite side to the hypotenuse in a right angled triangle. It's really important we understand which sides are the opposite and the hypotenuse. The eye of the angle looks at the opposite side, and the right angle looks at the hypotenuse. The sine of an angle is the opposite divided by the hypotenuse. We can use the SOH triangle to help remember the ratio. If we wish to find the opposite side, place our finger over the O, and that tells us it's the sine of the angle times by the hypotenuse. However, if we wish to find the hypotenuse, we place our finger over the H, and it tells us that the hypotenuse is the opposite divided by the sine of the angle. And having heard the recap, if you've understood all that, you've got the job done.